Okay, now let us solve the question number 36. We start the timer. A capacitor of capacitance C has an initial charge Q. Okay, so the moment is this is given here. Just write down the equation. Q is equal to CV. Okay, then the capacitor is discharged through a resistance of resistor R. The potential difference V across the capacitor varies with time. So V is a function of T. V is a function of T. So now you see there are several options here. Each of these options takes a long time. Okay, now what we do, when you say it's a function of time, what we'll do is we'll just write this as a Q by T. If I divide by this by T, what do I get here? I will divide this by CV divided by T over here. So which is nothing but I is equal to C into V by T. Now here if you see the option 3, it says rate of change of charge. Rate of change of charge is proportional to V. So which is seen to be a right answer. So therefore I can say C is the right answer. But how do I know that this is the right answer? Okay, because I have already worked it out. But from student's point of view, when you look at it, let us look at the first one here. RC by 2. After time RC by 2, potential difference across the capacitor is halved. If I look at this, so what you do is, you do it like this. Let us say for example, Q equal to CV. During discharging, we know that Q is equal to Q naught e to the power of minus T by RC. Right? So therefore, now if I put T equal to RC by 2, after T equal to RC by 2, I can get Q is equal to Q naught e to the power of minus half if I put RC by 2 here. Now we know Q equal to CV, right? So therefore I will write this as CV is equal to CV0 into e to the power of minus half. CC goes away, V equal to V naught e to the power of minus half. So definitely the charge is not getting halved, right? So therefore this is incorrect. Now then in a similar way, if you want to solve the rest of them also, so for example, capacitor discharges more quickly when the resistance is changed to 2R. So when the resistance is changed to R, when the resistance here is larger over here, definitely Q is equal to Q naught e to the power of minus T by RC, but it also depends upon the time constant. So therefore this also may not be the right answer. The time for the capacitor to lose half of its charge is ln 2 by RC. If I look at this one here, this becomes Q becomes Q naught by 2. It says half its charge, right? Q by 2 is equal to, so Q naught by 2 is equal to Q naught e to the power of minus T divided by RC. This is the, what is the solution for this? So this Q naught and Q naught goes away. E power minus T by RC. If I take the ln of this, I get half minus ln 2 is equal to minus T divided by RC. Okay, on all both the sides if I take. RT should be equal to RC ln 2. It's not ln 2 by RC. So therefore this is also incorrect. The right option could be C. If you want to validate all the three options, this is the way how you do. If you want to look at only one option, then the straightforward one would be, in one way, in 1 minute you can solve this one here. Okay, let us move on to the 37th question.